Good afternoon. Welcome to the Engineering and Construction Division of the U.S. Army Corps of Engineers webinar series. Today we have Metering by Design, which explores the evolving environment of utility metering programs through the presentation of metering hardware, software, communications infrastructure, system maintenance, and information assurance. Case studies will be used to illustrate the best practices and challenges of deploying and maintaining complex federal utility metering solutions. As usual, if you'd like to get AIA or learning units or continuing education units, we do them in batches of 5. Go to the Mercy website, the address is on the screen, and download the quiz for this session, and fill out the quiz and email it to the s_e webinar@usace.army.mil address at the bottom of the screen. And presuming you get the questions answered correctly, and if you include your AIA number, we'll register with AIA and get your learning units for you. Again, those come in batches of 5. We have a substitute speaker today. Excuse me. Mr. Phil Rector. Mr. Rector is an expert in the power and energy management field with over 27 years of experience that spans energy system sales, engineering management, offer marketing, and product line management. Currently, he serves as the manager for the National Solution sales for Schneider Electric. His tenure with Schneider Electric includes 11 years of directing global portfolio of engineering management software solutions. With that, I will turn it over to Mr. Rector.
Good afternoon, and thank you, Eric, for the introduction. Hopefully everyone is able to hear me quite well. We had a few technological barriers, but hopefully that won't prevent putting together a very informative presentation for you today. Eric, we can move on to slide 1.
Okay. Not all meters are created equal?
Correct. So with that, wanted to briefly go over a couple of bullet points here that explains why not all meters are created equal. Various manufacturers will put together a portfolio of what is termed as energy consumption and also power quality meters. So the difference being that the meter set itself is comprised of components that may focus on basically the amount of energy you're consuming, whereas power quality meters, as we will demonstrate through the presentation, really are a superset of energy consumption meters and various components that allow for very sophisticated power quality monitoring and consumption as well. Many of these meters come with onboard features, meaning they are consistent with things such as inputs and outputs, or I/O, memory storage to store data, as well as some of the meters will come with a set of web servers that allows you both to configure and also present information from the meter itself. Along with that, most commonly, most of the medium to high range meters are going to come with communications capability as well. And on top of that, you have the ability for alarms and or control through some of the meters, which again, on the subsequent slides, we'll go over a few of these different types of meters and the characteristics of them. Next slide, please.
Okay.
We look at really the evaluation of the metering value, and that value is often found when you look below the surface. You will see on the presentation slide here that we've really got in the central element of the presentation depiction of an iceberg, and really this is really comprised of different elements, being the tip of the iceberg, reducing utility costs. Further down into the iceberg, you see optimized equipment and utilization, as well as below that, improved reliability. And this really is a depiction of when you look at a metering set and you are evaluating the meters themselves. A lot of what we will talk about in this presentation is how to find that value underneath the top of that, the tip of that iceberg. So when you look at this equation, power and energy management, with the components that are involved in power and energy management, plus the dimensions that are involved here in the iceberg analogy, it really is totalizing what would be your increased efficiency, reliability, uptime, and revenue. And all those different dimensions as you look into that iceberg, and we'll talk about this in the presentation as well, how that drives that value of efficiency, reliability, and uptime. Next slide, please. So looking at that tip of that iceberg with reduced utility cost, really what you're looking at is three major components: meter application, cost allocation and utility billing, and utility reduction, implementation, and services. These are the main pillars, if you will, of that tip of the iceberg, reduced utility cost. And when we talk about meter application, we talk about things such as automated meter reading and energy monitoring, revenue metering and wages, water, air, gas, electric, steam, and other commodities, and the pulses that may be coming from those different types of wages meters, as well as tenant sub-metering. So this is where you really get into that deeper metering, where you're actually sub-metering different components, maybe tenants and or elements of load that you want to pick up in a sub-metering application. In the cost allocation and utility billing, the interval benchmarking and profiling is obviously very important here. You're able to also allocate energy cost appropriately. When we talk about allocating energy cost, it's not just the meter itself, but it's taking the meter components and the meter readings and subdividing those correctly to the actual constituents that need to basically be responsible for the amount of certain energy consumed. You also look at total load aggregation as well as utility bill reconciliation. On the utility reduction and implementation services, this is really where you get into the implementation and the ancillary services that come along with a metering program, where you're able to do the deeper energy analysis with some of the services, things such as power factor correction, lighting control, microgrid, and or demand shaving, load shedding, sequencing, and generator control. Next slide, please.
Okay.
The next dimension, optimizing equipment utilization. Again, the major pillars here are facility planning, improved efficiency, and improving maintenance practices. Under the facility planning, again, you're looking to identify equipment capacity properly with basic loads that you may want to and or equipment that you may want to monitor individually. Determine things such as transformer stress, and also maximizing equipment life. When you talk about improving efficiency, you look at balancing the circuit loading, improving the power factor, balancing generator efficiency, and optimizing chiller and mechanical equipment. Under the improved maintenance practices, really this is where we talk about the equipment or load monitoring, such as transformers, MCCs, and switchboards, switchgears, capacitors, generators, PUs, UPS. All of these things go towards optimizing and getting the most out of your equipment. Next slide. And completing the dimension in terms of the iceberg around metering value is a dimension of improved reliability, which is very important. System monitoring and analysis, power system automation, preventive maintenance, advanced diagnostics, power system engineering, and consulting all fall in this dimension. And obviously, and as it's depicted in the picture with the iceberg, again, this is where some of the biggest savings can occur. So really, when we talk about the value of metering with the three pillars, as you look at the iceberg, again, as you drive deeper and deeper and deeper into that iceberg, the amount of savings potential improves. Obviously, with things such as system monitoring analysis, again, depending on the type of infrastructure, what you have and what you need to basically monitor and solve are things such as transient voltage, disturbances, power quality, and harmonics. These are elements of a potential power system that, in some ways, and in some explanations, it can be quote unquote death by 1,000 lashes. Meaning these are things that are happening inside of a power system that sometimes without advanced metering you just can't catch. But it does have a severe effect on the electrical distribution network. And most of the time, these are common elements that can cause either disturbances and or internally to a network or internally to a network distribution system can cause outages and or failed equipment. Power system automation, things such as automatic throwover systems, load preservation, preventive maintenance, things such as generator testing and documentation, which illustrates here in the brackets there, JCAHO, which is a compliance most likely found in healthcare organizations where there is an expected amount of testing and documentation that you have to provide within a healthcare system, operating a healthcare system that's mandated. And things such as remote alarm notification as well is very important. Advanced diagnostics, sequence of events recording. This is where you really get into what happened in a disturbance and or something that happened on the power system where without metering and sometimes advanced metering, you just can't see what's going on. Also GPS time stamping, where you're really needing very, very finite time stamping capability down to the millisecond. And also root cause analysis, finding out what occurred, what happened without sequence of events, recording, and sometimes GPS time stamping, that root cause analysis, you're just not going to have enough information to diagnose that problem. And then, of course, on the consulting and services side, going along with that, you have safety and code compliance, electrical distribution, system assessment, as well as system studies. Again, many times the information coming from this metering is what they are looking at to provide that consulting or that engineering system analysis. Next slide, please.
Okay. Okay, can we hear? Okay, there we go. We're back on. All right, sorry about that, folks. Okay, let's pick up. We're on the slide critical facilities demand and reliability and efficiency.
Okay, hopefully everybody can hear me now. Hopefully there weren't too many slides that there wasn't any audio for you. So I'm sorry if we skipped through a couple, but picking up where we talk about critical facilities, demand, reliability, and efficiency on those two spectrums that are so important. We've got just a little bit of insight here on the segments and which segments really tend towards the reliability side of the value, and then those that really tend towards the efficiency side. And looking across left from right, where you have the different segments, I'm not gonna go into them, but basically when we talk about the savings potential between the reliability and efficiency, you can see here how different types of segments and/or markets, processes really tend to value, either high efficiency, or reliability. Obviously, utilities and data centers, hospitals, they really tend towards the reliability side, while government, university, and really commercial properties lean towards the efficiency side. The amount of savings potential with each segment and category. Next slide, please.
Yeah, hang on a second. I have no next slide buttons. Kelli, if you're on, I think that when I exited off and came back on, it must have made you the presenter. If you could pass presenter status back to me. I don't see any buttons. Yep. Well, somebody did change this slide. Or do you want to just accept, just keep doing the slides? Okay, now she's on metering cost effectiveness.
Okay. So continuing on with regards to the effectiveness of putting together metering costs, really what you're looking at are several categories where it's not just the hardware, but it's also the communications that are available for that hardware, as well as the supplies, the wire conduit, junction boxes, labor, and reoccurring costs. Now, I'm going to try to flip through these slides as best I can so that we are allowed some time for questions and answers during the end. So hopefully you're able to kind of browse through the slides and look at what we're talking about with those different categories of metering cost estimate. Next slide, please.
Oh, okay.
Look at effectiveness.
Okay, yeah, there, the table. Okay, we're there.
Metering cost effectiveness, when we talk about the actions versus the associated observed savings, we talk about the installation of meters, you're looking at, really, up to 2% just by that Hawthorne effect of, basically being aware of the meters themselves and being able to monitor. When we talk about bill allocation and being able to properly allocate associated responsible, let's just say, tenants and or associated ownership of a bill, you're looking at 2.5% to 5%. When you talk about tuning up a building, again, this is where the greater savings come in, where you're looking at improved awareness and identification of simple O&M costs and improvement, where you look at anywhere from 5 to 15%. And then this element of continuous commissioning, where it really is a cycle that really never stops. You're continuously looking for more improved opportunities, where you're looking at that bottom part of that iceberg with 15 to 45% potential savings. project accomplishment, measurement, and verification often comes into play, where you're looking at, again, improved cyclical type of opportunities by continuously commissioning the system. Next slide, please. So again, with that idea of continuous commissioning, you're looking at that maximal extent practical. And really, to determine the cost effectiveness, you need to look at the cost of the design, the purchase, the installation, the maintenance, the storage of all the data, and obviously ongoing operation of the metering system. It allows you to analyze the information, not just necessarily the data output, but when we talk about looking at a system, you're looking at really the information that system allows you to have. Next slide, please. So we have on here cheap metering, and it's basically penny-wise, but sometimes pound-foolish. And really what we're talking about here is that you're not always going to find the amount of savings and or the amount of information that you need by necessarily going with the cheapest meter. It's very important to match up the right type of metering with the right type of application that enables you to, one, extract the full value from that meter, and two, be able to properly summarize and properly show that return on investment. And we'll get a little bit more into that here in the subsequent slides. So looking at that return on investment, the big picture, where you're looking really at the two pillars of saving energy and improving reliability. Again, I'm not going to go through each one of the lists here. I'll give you a second to look at it, but really those two dimensions, those two sides of the spectrum, are really what drives that return on investment. And again, looking at saving energy, when you look at the different opportunities that you're afforded with different meter types, obviously it's not always going to be a basic meter that's going to drive those potential savings. On the improved reliability side, again, depending on the application of the meter, you want to place the right type of meter in the right type of application that allows you to do what it is that really, really helps you to, one, prove that ROI, and two, get the maximum value out of that metering placement. When you talk about reliability, things such as voltage notching, voltage unbalance, harmonic distortion, power factor correction, and sequence of events recording are just a few of those elements that are probably not going to be available in a meter that's on the lower spectrum of the metering categories, meaning a basic meter may not be able to drive and provide that type of application that you're looking for. Next slide. Metering approaches and technologies. Let me know, Eric, if we don't, if we're not on the right slide.
Okay. Yeah, meter approaches and technologies.
Okay. Again, metering, the components of a metering system and also the approach to it, we're talking about, four major categories where we talk about the meters themselves, the data collection. What type of data collection? What type of system do you have? And what is it that you're wanting to really extract from a system where you may have different various architectures, different system types, or the need for some complex and or let's just say, non-wired connection system where we may talk about phone modems or some type of radio frequency, wireless system, etc. Those all have to be evaluated when looking at the metering system components. Also, the amount of data storage that's available, as well as the information that you're looking to extract and or present is also important when considering the meter system components and technologies. Next slide, please.
Okay.
I spoke to systems and components.
Yes.
Looking at basically the differentiation between circuit monitors and power meters. When we talk about power meters, really that's the design criteria of the meter. It's really considered a power meter because it's basically monitoring the power with basic elements, where we're looking at things such as voltage, current, power factor, etc. And so the meaning of this slide is just to actually show you and illustrate features versus value that can be extracted, as we talked about the iceberg, and really being able to go deeper and deeper into the savings potential with what we would call a more advanced circuit monitor. As you look at that spectrum of power meter versus circuit monitors and the associated capabilities, whereas you move up the line, you're talking about things such as sag and swell detection, advanced control, transient disturbance capture, flicker. Those are all elements that are something to consider as you are trying to place a meter, put a meter in place, and extract a full value as well as solve potential problems. Next slide.
Okay.
Associated with the metering is system and components, looking a little bit deeper into that, where we talk about sub-meters and branch circuit monitors. Again, a different category necessarily of metering, and the reason why we talk about these categories are these are, again, very important to consider when talking about the equipment and or the loads that may need to be monitored beyond just the building or the main entrance. When we talk about this, these types of meters are really important for things such as tenant metering and cost allocation and power distribution unit monitoring, as well as looking for monitoring single and or potentially multiple circuits that are associated inside of the electrical distribution network. These more than likely are the meter types that are going to come with very simple type of installations, where you either have the meter designed as a clamp-on CT that actually monitors the actual load potentially and or equipment, as well as something such as a high-density meter pack that allows you to monitor in multiple circuits in a highly populated electrical distribution network, such as a high-rise building with multiple tenants, etc. Next slide, please. Going deeper again into the systems and components, when we talk about communication devices and accessories, obviously when we talk about communication devices, these may come in many various forms. Obviously there are meters out there that come along with the communication devices, the gateways embedded in them. such as the CM4250 there that's located with multiple options, such as an ECC Ethernet card, and that's really stands for Ethernet Communication Card. That's designed to actually plug in as a component to a meter. Or you have individual communication devices that can pull in and communicate via Ethernet or RS-232 or something like that, where you talk about the serial communication and be able to pick up points from multiple and log, actually, multiple meters. Accessories, we talk about inputs and output modules, CTs and VTs, GPS time synchronization, portable meter enclosures, satellite time system synchronization. All those things, again, are something that depending on the type of meter, can be configured in a meter and or added on to it as a modular element. Next slide, please.
Okay.
Now, when we talk about collecting the data, that's really the important side of this, is collecting the data that's inside of these meters and that can be accumulated to obviously present the information. Again, some of the data acquisition characteristics that are common out there, where you're actually looking at combined metering, such as, not just electricity, but other commodities such as gas and steam, air and water, that wages term again. Again, that is important to be able to understand and to know about potentially in just a meter selection criteria, because there are meters out there that can pull in inputs and collect that information and store that information for all of those wages, and then there are meters that may not come with the capability to monitor all those different inputs. But you're also looking at things such as monitoring your distribution system for electric meters, circuit breakers, protective relays, almost anything on the electrical distribution network is something that you should consider potentially as something that you want more of that information, that data acquisition. There's also the capability to interface with third-party meters, transducers, PLCs, RTUs, distribution equipment, and mitigation equipment. Also a consideration is security, obviously, and the ability to integrate with other systems where we potentially are looking at different systems like energy management systems, SCADA systems, DCS systems, ERP systems, or building automation systems. And then there's the integration side of it, that not all meters are created equally and or the same. So you look at standards for communication such as of this data, such as ODBC compliant databases, XML format, OPC, email, FTP, CSV, PQDIF, and web services. A lot of alphabet soup there. But these are all different types and forms and formats of data that are out there that you want to be compatible with under the data acquisition term. Next slide, please. Obviously, and I'm not going to speak long about this slide, but basically there are approaches and technologies that when you look at it from a generic standpoint, you've got one-time or spot measurements that are needed from a system or a subsystem, runtime measurements where you're continuously connected, short-term monitoring of the building, and long-term monitoring system and the whole building. So again, these are really very, I would say, high-level considerations. Next slide, please. When we talk about the cost effectiveness, again, this is an equation, I guess, that is also found on the DOE site that you can go and look at. But basically, what it's saying is the install cost by the simple payback plus the annual cost. When you know a factor, if it's the minimal annual electric bill and or the savings that you're trying to achieve, this equation is commonly used. Next slide. I've got a couple of kind of use cases here spelled out in case 1, 2, 3, and 4, where the installation cost, the payback, the annual cost associated with the monitoring or metering program drives the percentage annual savings and or allows you to look at the right type of expected meter and or the desired payback, given that you either have the minimal annual electric bill or you're looking to solve that in terms of trying to find out what it should be, what it should look like. Kind of getting close on time here, so I'm going to move on. Next slide, template for metering plan.
Yep.
What you're going to look for is you're going to look to set the goals, identify, confirm, and prioritize those goals, and formalize what the expected or needed outcomes are. In terms of the metering program structure, again, you're going to want to look at what kind of data you're going to look to extract, whether it's power quality data or basic voltage, current, and power, the equipment needs that are associated with putting that metering into place, what you have as an existing infrastructure. We went over that a little bit in terms of whether or not you're going to be able to use Ethernet, or there's an associated load that you need to pick up somewhere that's remote, and you may have to look at going to something like a wireless communication in order to get that metering information connected to a system, because you may not be able to run lines Cat5 or whatever out to the structure itself. Then you're going to set cost and benefit criteria as well as prioritize the opportunities and develop what it is that you're looking, that KPI that you're looking to get out of that metering plan. Next slide.
Okay.
Methods of prioritizing buildings. Prime consideration is the amount of electricity, critical loads, the cost of the associated electricity that you're looking at, and the expected estimated benefits from the metering program. Some of those things you may want to potentially exclude are things such as low energy intensity buildings, where it may be that there's just a minimal amount of the lights need to be on. That may not be something you're wanting to focus on, and or small buildings, and or potentially leased buildings. And then obviously periodically revisiting that to look at that building priority list. Obviously things that affect that are technology changes and also economic changes. Next slide.
Okay.
I'm not going to spend a whole lot of time on this slide. Jim Plourde is an expert on this side, but again, he speaks very well in terms of the different opportunities and or methods that you may find in actually financing a metering program. Obviously, there are things such as energy savings performance contracts, utility energy service contracts, UESCs, utility company financing. You guys can probably look through the list here, but there are obviously a multitude of ways that you can potentially finance a metering program or metering installation potentially. Next slide, please. Nope, that was...
That's it.
That was it.
Yeah, so now we have 10 minutes for questions. Now, our original speaker, Jim Plourde, as you said, was the the expert on that last slide, especially. So whatever questions we can't answer, I invite people to note that email address and phone number on the screen, so that they can tap him if they don't get the answer they're looking for here. We did have one question typed in. Again, people who are new to this venue on the webinar, there's a chat window on the right-hand side of the screen with a text entry block at the bottom of it. Type your questions in there. I will read them aloud for our speaker to answer. And don't be alarmed if I skip over your question, because sometimes I try to group things together in subject matter or go back and forth and prioritize as time allows. So with that, the first question was actually from about halfway through the presentation. It's what is shadow metering?
Good question. Hopefully I'm still plugged in on the audio side. Shadow metering is really where you're looking to shadow the utility meter. So on the incoming main of your building, where the utility is just on that supply side of the transformer potentially, or the delivery side, and they're monitoring or have a meter on that side of the, let's just call it the fence. Shadow metering is something that you would want to have as a equivalent meter and or better meter that allows you to basically cross-check and provide some type of verification that the utility meter is actually correct.
Okay. Now, would the utility meter be on the would these meters be on both sides, on two different sides of a transformer or something, or?
Well, it depends. It depends on the installation and what type of I guess distribution network you would have. But quite often, what you will find is that the meter is sometimes placed in an area where it could be either load or supply side, depending on, again, the nature of the distribution system coming from the utility. So what you would want to do is you would want to match that meter on the same side if potential. Now, if it's on the supply side on the supply side coming in from the utility, where sometimes typical application may be if you have multiple entrances, sometimes the utility will actually put a what they call a multimeter or something like that on potentially a pole. Obviously, you're not going to be able to match that. You're not going to be able to put a meter on the same on the utility's pole. Mm-hmm. So you would want to locate that meter as close as you can to that supply side meter. So it may be on and quite often utility's not going to let you put a meter on the supply side when it's in that fashion. So you would want to put it on the load side of the incoming transformer.
Okay.
But typically, what you want to do is you want to be able to place that meter as close to the utility meter as possible.
Right, so you don't get any line losses throwing the numbers off or anything like that.
Correct. Correct.
Next question is.
That's a great question, but there are meters that will actually account for that as well.
Oh, nice.
So even if there are meters that are placed, or you want a shadow meter that's on the supply side, a lot of the more advanced meters will account for that line loss.
Okay. The next question is the meter manufacturer taking steps to ensure cybersecurity is implemented at each level of the metering systems?
So I think that question hopefully is in terms of risk management, et cetera. So by design, there are meters that are associated, cybersecurity elements that will need to be potentially turned off. based off of risk assessment, but there are, for example, Schneider Electric does provide risk management framework associated testing and compliance on the meters themselves. And sometimes that does permit and or require some level of remediation, be it that a meter element has to be turned off. But in most cases, when we're talking about the design of a meter, obviously there are a lot of different security requirements associated with that, different private versus public versus government associated with cybersecurity. So a lot of the elements that would present risk in a cybersecurity kind of audit, those features, for the most part, depending on the age of the meter, can be turned off. Some of your older meters may not have that capability, but the newer meters should have that capability.
Okay.
Hopefully that addressed the question.
All right. If not, Mark, just feel free to post a follow-up question. Let's see. Here's another one coming in. Oops, we're scrolling a little bit. Okay. We will post the quiz later when we get them available. We'll have to get a couple updated, as well as the video if it actually managed to record. Our next question is, what are an installation's options for connecting legacy meters to a network?
In terms of legacy meters, depending on the communications capability, there are legacy meters that may go back to proprietary communications. There's an answer to the problem as long as the meter itself has a communications capability. And for example, an add-on module that may be needed to be added to the meter. The other, I guess, going back to the earliest days of what we would call digital metering, most of your meters communicating or came available with some form of communication. And so there might be a little bit of communication engineering that has to be done, maybe another module, a converter, et cetera, that's needed to be installed to convert whatever protocol it is communicating to a protocol that matches your infrastructure, your communication network. So, for example, going from something as old as an old SIMAX protocol through a converter that converts SIMAX to Ethernet so that you can put it on the Ethernet hub. That's just an example.
Okay. I'll give a minute for anybody else.
Hopefully that answered the question.
Oh, yeah. I hope so too. Okay, let's see. What you mentioned here is a smart meter that also has energy management modules associated with it. If we already have energy management systems in our facilities, then there may be redundancy in much of what has been said here. How easily do these meters Nicholas, I think something may have got cut off. The chat only allows so many characters in one block. Interface. Oh, how easily do these meters interface?
Okay, so if I understand the question, there's an existing energy management system, whether it's whatever vendor's meter along with metering system or metering software. When you look at the communications capability of any newer meter, it should be able to communicate even with an existing EMS system. And again, that's where it may require a certain ancillary product, communications card, and or converter to go from one protocol to another to get it on that network. Hopefully I addressed the question appropriately.
I think that's how I interpreted the question also.
Okay.
We are at 3 o'clock on the dot, and we offer many thanks to Phil for stepping in for Mr. Jim as last second, literally, and making this happen. It looks like we had a good turnout. There were over 70 people online, and despite our hiccups with DCS, we seem to have managed. So if anybody has any questions that didn't get answered, or if you have any questions that you want to look back at this email address or phone number or at these slides, there's the icon on the lower left with the down arrow on it on the screen underneath the slide. You can click that and download the presentation for your reference. I'll leave this window up for a while to give you all a chance to do that, for those of you who want to do that. And again, thank you very much. I'm going to stop the recording and put my phone on mute, or sound system on mute from here on out. And everybody, thank you for attending. And again, thank you for our speaker, and have a nice day.